In this problem, we're told that the amounts of weight that male college students gain during their freshman year are normally distributed with a mean of 1.1 kilograms and standard deviation of 4.8 kilograms. So in part A, it asks if one male college student is randomly selected, find the probability that he gains between 0 and 3 kilograms during freshman year. So here we're looking at a distribution, a normal distribution, where the mean is 1.1, and we want to find the probability that the amount of weight gained is between 0 and 3 kilograms. So I'm drawing a rough sketch here. It doesn't have to be super precise. I just want to visualize the fact that we're between 0 and 3. So I'm going to use the normal CDF function. That's how I find a probability. So whenever we're looking for a probability, that's the function to use. And we know that the lower boundary is 0 and the upper boundary is 3. The mean is 1.1 and the standard deviation is 4.8. So this is similar to what you did in section 6-2 on working with the normal distribution that is not a standard normal distribution. And when I put that into the calculator, I find the probability is 0.2445. Okay, so almost 25%. In the next problem, so here we're going to contrast these two problems. It's a little bit different. Here it says if 25 male college students are randomly selected. So we're selecting a sample, and that's the key here. I want to find the probability that the mean weight gain is between 0 and 3 kilograms. So in the previous problem, we were finding, I'm going to put it up here, the probability that the weight gain, which is our random variable, was between 0 and 3 pounds. Now we're going to calculate the probability that the mean weight gain is between 0 and 3 pounds. So we have our lower and upper boundaries, which are going to be just the same as for the previous problem. But here's where it changes. Now we're going to look at the mean of the sample means. Well, that's straightforward because that's just equal to the original mean, and that is 1.1. But then I have to look at the spread of the sample means. And that is the original standard deviation divided by the square root of the sample size. So here I'm going to take the 4.8 divided by the square root of 25. So while we're working with the same boundaries and the same mean, the distribution is going to look different. So our distribution now is going to have a higher peak, still at that same location above the mean, and the spread is much less. So still trying to make this look like a normal distribution, but we're going to see that this area in this particular problem is going to be larger. That's taking up a lot of the area under the curve. So, how do I put this in the calculator? I'm going to do normal CDF, 0 and 3, mean is 1.1, and the standard deviation I'm going to type in as 4.8 divided by the square root of 25. Now you can calculate the square root of 25 in your head, and that's just 5. And then you could divide 4.8 by 5. But if that had not turned out to be a perfect square, the 25 was not a perfect square, then I want to just go ahead and type it in just the way I have written out here and put a parenthesis on the end, which is kind of optional. And so that way we get a very precise value in there for the standard deviation. And when we calculate this, we find our probability is 0.8502, so about 85%, and that makes sense when we look at that distribution there. So in C, it says, why can the normal distribution be used in Part B, even though the sample size, it does not exceed 30? So the sample size is technically too small. We only have 25. But the key here is that the weights are normally distributed. Oop. Here's what I'm looking at right here. So we have to have either our population is normally distributed, or our sample size is greater than 30, or both. You know, that would be even better if both. But you, at a minimum, you need one or the other. So let's see. Since the weight gain exceeds 30, no, that doesn't make any sense. Since the original population has a normal distribution, okay, so that's what we just said. The distribution of sample means is a normal distribution for any sample size, and that's the one that we want to choose right there. Okay, so that's how you do that problem.